And we are live. Sorry for the technical difficulties, but welcome to the first ever Haas Virtual Demo Day Live. We're here at the Haas factory in Oxnard, California, and I know a lot of you are used to going to demo days at your local HFO or Haas factory outlet. Obviously in 2020 things have changed quite a bit. We hope you're going to enjoy this. We've got a lot of information to give you and a lot of cool machines. Real quickly, you notice this is Senior Applications Engineer John Nelson wearing a mask. I'm holding mine. Everybody here at the factory wears a mask from the moment we walk in the door until we walk out and get into our cars. We've got a temperature scanner that checks us all as we come in. We're keeping everybody here safe and keeping the factory open to support our customers. All right, let's get in position over here and we'll get started. So there's a couple of ways you can watch. Watch your step there, Tyler. Our cameraman's walking backwards over a bunch of cables. So you can watch us either on HaasCNC.com or on the Haas YouTube channel. And we've got a chat element in there, and we encourage you to ask questions or even just type comments, and we'll try to get to them either while we're talking here or at the end. We've got 4 locations we're going to be at today. The first one is here. If you've ever been at the factory, we're in building 2, which is by the products and the training area, and that's where we're going to talk about the UMC 1500 Duo. After that, I'm going to throw it to Andrew Harnett and Bob Singh. They're going to be in the demo room up front. We're going to talk about the auto parts loader, or APL, on an ST20. And then right next to that, Andrew will get with Milton Ramirez, and we'll talk about the mill APL. While all that's happening, I'm going to walk back to the demo room, and Corey Sullivan and I are going to talk about the new Haas robot package, easy for me to say. So again, thanks for joining in, spending a few minutes with us today, and that's enough of me talking. Let's get started here. John, let's talk about the UMC Duo.
Okay, so UMC 1500 Duo is a perfect marriage of a UMC 750 and a VF2 YT. We have 2 distinct machining areas inside of the machine. We've got the 2-axis rotary setup right out of the UMC 750. And then over here, we've got a stationary table that's approximately the sizes of a VF2 YT. It's 32-inch by 18-inch, standard T-slot table mounted on the thing. So the machine is essentially a UMC 750, but we've stretched the X-axis to give us 60 inches of travel so that we can have different things set up. I've got some vices over here on the stationary table. I've got another 5-axis vise on the rotary product. And as a matter of fact, the UMC units now have a machined area on the side. We can mount a vise and set up another workpiece over there on the side. Yeah, let's check that out.
Tyler, are you able to see inside the machine? You can come up closer.
So here you can see we've rotated the rotary table up to 90 degrees. Here's my standard 5-axis setup, and then I've got another vise mounted over here on the side to do additional work. If I'm cutting a dovetail to hold my part, I can start here on the side and then flip it over, whatever I need to do. So the machine really has a ton of versatility. There's hundreds of ways that you could set this up. I picture this machine being for the job shop, really, so that you can have different work holdings set up over here on the table. You can have a completely separate job, or if you have a particular part that you're making that's got many different operations, you can have op 1, op 2, op 3 over here on the rotary, however you want to run it. If you're familiar with Haas products, to give you an idea of the size of this machine and the width here, it's about 3 inches shorter than a standard VF5, and in the depth of the machine, it's about 13 inches deeper than a VF6. So essentially, it's a medium or a large VMC size machine, and it's got the UMC height with the roof on top to keep the chips in. All of the design changes that we put into the UMC 750, 1000 and the 500 models have been incorporated in this machine. So the main thing is that the doors are now mounted inside of the enclosure, and because the opening for this machine is so much larger, we've got the double door. If you're working over here on the rotary side, you just need to open, halfway, and you're changing parts over here. And obviously, if you need to get to the stationary table over on this side, you open the door all the way. So mounting the door on the inside of the enclosure allowed us to bring the pendant mounting from the side of the machine around to the front. So previous models had it on the side, now we've got it on the front. It's much more convenient for the operator here. You can see I've got more convenience features than the previous version of this model. And also putting the door on the inside of the enclosure allowed us to put the tool rack on here, work table, tool holder vise, and so forth. Wash down hose as well right in the front. So it's very, very similar to many of the other Haas machine products that we build as far as look and feel of operator convenience in the front of the machine.
Right. Everything's at your fingertips, in other words.
Yeah, absolutely.
Let's talk about some of the standard features versus optional features.
Okay, so this machine is a dedicated 5-axis machine, and like all of our other dedicated 5-axis products, it comes standard with dynamic work offsets and tool center point control. It also comes standard with the probing system. It has VPS templates in it to determine the rotary, machine rotary 0 point, MRZP. So all of that stuff is included. This machine is the SS version, the super speed version. So it also comes standard with high-speed machining. The non-SS version, high-speed machining is an additional option.
Is option, right?
Yeah.
Spindle, standard spindle is?
Yes, so the entire spindle head, spindle configuration, and spindle head right out of the UMC 750. So on a standard UMC 1500, the standard spindle speed is 8,100 RPM with upgrades to 10, and then the SS version starts at 12,000 RPM with a possible upgrade to 15,000, and you can get the HSK 15,000 in this model as well.
Great. Tool changer, 30 pocket standard.
Tool changers, 30 pocket standard with optional 50, and these are the direct positioning high-speed carousel tool changers. And then the tool change on the SS version is the high-speed tool changer.
It's the super speed, like an SS model.
Yeah, like all of the SS models.
Okay. This table's at 90 degrees. When the table is flat, what is the difference between platter height and table height?
So the table and the platter height are at the same level. So you could fixture a long part and use that entire 60 inches of x-axis travel to machine a long part.
Got it.
So it can be set up like that. Centerline of the rotary is about 2 inches above the stationary table over here.
So you'll need to consider that.
If you were going to mount a tailstock, you'd have to make something custom for you at this particular time.
For 2 inches.
Yeah.
Okay. Let's talk a little bit about the construction of the machine. Tyler, I know it's tough dragging those cables around, but let's head to the back.
Sure.
Actually, let's make a stop here at the side if you don't mind.
Yeah, as I mentioned before, mounting the pendant on the front of the machine opened up the side and gave us the ability to put a much larger window here, and it's a sliding window, so I've got good access to my work holding. This is also a really good place to clean the machine from, get the chips down into the conveyor.
And if you want to add automation at some point, it's a great spot for a robot or an APL at some point.
Exactly.
Perfect.
Exactly.
All right, let's go around to the back of the machine. Tyler, if you don't mind. Hey, Corey, can you help with that cable, please? All right, John, I'll let you take this.
So you can see in the back of the machine here, we've got the double bridge, the double arch. The standard UMC 750 has a single arch with a 30-inch travel for the x-axis, which we see across here. And to build this machine, we just made a double arch version of that bridge, extended it to 60 inches, and that's really it. I mean, as far as performance specifications from a UMC 750 to this machine, they're identical with the exception of the x-axis travel, which is 60 versus the 30 on the UMCs. So we can see under here in the same location, we've got the rotary mounted in the same position, the tilt axis rotary, brakes, brake, hydraulic fluid reservoir, and so forth. The base has been extended to accommodate the additional x-axis travel. Around here on this side of the machine, we've converted the 750s to take the standard 55-gallon coolant tank with an optional 95-gallon available. So it makes it much easier to clean the coolant, clean the machine.
Okay, let's go back around to the front. Tyler, I know I'm making you move all over and focusing is impossible. Apologize for that. Let Tyler get in position here. So we've got a demo to run. Now, normally when we make demos, you guys have all watched our demos on the website and on YouTube. We've got GoPros inside the machine. We have a couple of cameras. We're going to take this demo, do a full-blown video on it, and post it on YouTube and on the website in the next couple of weeks. But for now, we're going to run it and just put the camera through the window. Explain what you're doing here. Well, before we start that, who would buy this machine in your estimation?
So I think the target audience for this machine is the job shop, the guy who's changing setups a couple of times a day or at least 3 or 4 times a week for sure, because of the versatility. There's so much stuff that you can put on here, leave it. You don't have to set it up, run a job, tear it down, put something else on. You can set up a job, run it, leave it there, set up something else over here in this area. You could even utilize the side vise if you need it for a third job and leave everything else set up. If you're going to get back to that in another week, you're going to make some more of those parts or whatever it is. That's the main focus that I see, but certainly manufacturer, somebody making their own product could utilize this machine in a way where they could be making a couple of, each cycle could produce parts over here and a different part here. There's just so many ways. It's so versatile. It's a terrific product.
Great. Okay, we're going to run the demo. You want to get started here?
So I just wanted to mention that the part we're running over here on the 3-axis side on the stationary table, the 3-axis part is all tooled up with HaasTooling.com. And as a side note, I headed up the group that did the testing of all of this tooling that we're selling, and it really is good product. I want to stress that this is not cheap stuff. We went top shelf all the way on these products. It's great tooling. Okay? Thanks.
Okay, Tyler, jump in there. We'll get it started.
Should be ready to go.
I'll have to read them all. And you want to look pretty good.
So we got a couple of questions that came in while Tyler's showing you the demo. We got one from Melon Gum here. What is the max RPM? So this particular machine, the max RPM?
15,000.
15,000. Now again, the SS model, standard is 12,000 RPM with the 15,000 RPM option.
Correct.
This particular machine is 15K.
A question I have here is, what is the size of the table? So the rotary table is 500 millimeters, that's 19.7 inch diameter T-slot table, and the stationary table is 32 inches long and 18 inches wide.
Great. And then one more here from Benjamin Carlson. What mount is on the side where the vise is? T-slot or threaded bolt, threaded holes with a bolt pattern? I'm not sure which side he's talking about, but...
I'm assuming he's talking about the side of the trunnion at 90 degrees. There are 3 holes drilled over there. They're tapped with a half 13, and they are on a 4-inch width and another hole at 5-inch width.
And one more question from Marcus, and I'm not even going to try to pronounce your last name. Sorry, Marcus. Does this machine have a mist extractor as an option? Yes, absolutely.
It does.
You can't see it, but it mounts on top of the roof, which is included with the machine.
Yeah. And this particular one does not have it installed at this time.
All right, we know it's tough to see this demo. Appreciate you guys hanging out. I think this is a good time to throw it to the demo room. So Andrew, it's all yours.
And this is Bob Singh. He works as a product specialist, having mostly to do with turning centers and everything related to that.
Yep.
And we're of course standing here in front of the automatic parts loader as it's fit up to this SC15Y. And I mean, what's the main reason that you want an APL fit to your machine?
It's automation, being able to run parts unmanned for a set amount of time or a set amount of parts. It allows the operator to go run other machines, perform other duties.
Right, press cycle start here, let this thing run, and go over and work on a different machine, right?
Exactly right, yeah.
Cool, okay, so in a second we're gonna do a demonstration, but also I just wanted to mention that I've got the chat on my phone here. There's nearly 600 people watching right now, so thank you very much for joining us. If I see a question on here that we can field while we're talking here, then we'll try to get to that. Otherwise, we'll probably wait until the end of the presentation, maybe even until we get done with the next machine to answer a bunch of those questions. So we want to start by demonstrating how this thing loads and unloads parts, right?
Yeah, the APL's already in the middle of a sequence, so I'm just going to explain before we do press start, because it is such a quick
it moves
sequence.
kind of quickly, so it's a little bit difficult to explain it as it's going.
As soon as I press start, the turret's going to clear a path for the APL to come down to unload the finished part that we just ran, flip, and then load a rough blank, and then go back to the home position.
Right.
Yep, so
cool. Let's do it.
Okay. So that noise you can hear right now, that's the turret clearing a path for the APL.
Right, it's moving back out of the way.
Yeah, and the door's going to open. Your light curtain just triggered.
Just ran through the light curtain there.
I'll do that again. Uh-oh.
There you go, I've already messed it up for us. Yeah, so it's got this light curtain on here and I just interrupted the beam.
So we have to send it to recover mode.
Okay, so we're going to reset it since I just interrupted it.
Yeah.
So actually, as we're going here, I see a question from Benjamin Shockley. It says, how many parts can it do in one job? And so it pretty much depends on how many parts you have here on this template. And that can be anywhere, like in this case, we've got, let's see, it's, we have 40 parts on here total. Right now we have 24 lined up. Bob's just reloading this thing, got out of sequence.
Yeah.
So you want to show lining it up first, or?
We're just going to start from the beginning so we can show the pickup and then the load.
Okay,
go
cool.
From there.
So instead of starting halfway through the motion here, we'll start all the way from picking it up on the table. The beauties of starting in the middle of an automatic sequence.
we'll get it going again.
So anyway, you can run, of course, if you have smaller parts, the APL comes stock from the factory with 3 different size templates, kind of a small, medium, and large. And so the small one, you're going to be able to fit more parts on it. We'll show you later that when you're, I'm sorry, go for it.
Ready. We're gonna
go for it. I'll stop talking for a minute.
So the ramp's going to come down, pick up the raw blank, go to a safe location, flip to the ready to load position.
Right. So now the raw slug is ready to go into the chuck.
Yep.
Into the chuck.
Clamp the raw slug. The grippers will unclamp. The APL will now go back to the table, pick up the next raw slug while this is running.
Right. So we don't have a part running right now. Just because that would take extra time. So we were going to show you unloading your raw slug, but we since we're not, well, you'll see this thing pick up the next raw slug, as Bob was saying.
Yeah. So while the machine's running, the raw blank is above the machine, ready for the next load. So it's not all the way over there. It's right above the machine, ready to do the load unload. So
right. Now we showed you already how the light curtain stops motion.
Yeah.
Now the beauty of it is, even if if you've got someone in the shop that maybe isn't experienced with this machine or maybe is new on the job, if they walk in here and interrupt this beam, the APL motion is going to stop wherever it's at.
Yeah.
And the beauty of it is, the machine, if the turning center is still running, it's not going to stop. It continues the machining cycle until it's complete. And the APL can be started again just by hitting cycle start.
Yeah, so we're going to show that sequence I was telling you about earlier, where it's going to unload the finished part and load the raw blank.
Right.
So we can see that. So you can see the part flip inside the machine. It's going to pick up the completed part, clear the jaws, flip to the finished part, put the rough part in, unclamp, and again go back to the table.
Right. Right. So there's the second half of the operation.
We're back to normal now.
Yeah. Next time, don't step in front of the light curtain too early. That's what I need to learn.
Well, we can
So
show
now
that.
as it comes over here, see if I reach in here and I'm not used to this machine, this thing is going to stop, so there's no chance of me getting hurt.
Correct.
As we were just mentioning, we can still easily restart it.
Yeah, and just to mention, the machine is still running when the light curtain is triggered off. But easy way to start it, press start, it doesn't disturb the machine, it continues. Now it's flipping to pick up the next raw stock that we just saw it perform earlier. So, shall we get in there?
Okay, so let's stop it again. So now that we're over here, we want to talk a little bit about these templates that come with the APL.
Yeah.
So
There's 3 sizes of templates that come. It's small, medium, and large, and depending on what size or what diameter your slug is, will determine which template you're going to use. Now, this blank is 3-inch diameter. The medium template is 2 to 4 inches. So that's the one we've chosen right now.
right, and so there is some adjustment built into these. Well, there's quite a bit of adjustment really built in. It's kind of 2 sheets, one on top of the other.
Yeah, you can adjust it to where you want. I don't know if you can see from over there, but there's about 1/8 of an inch around this slug that you can move this around, and it's completely safe. It'll still, wherever you position this, the gripper will pick it up.
Yeah, as long as you're inside the pocket. And if you have, if you've got really rough raw stock, you might give yourself a little more room. Maybe you've got really accurately sized bar stock. You're going to make it a little bit tighter. But as Bob was saying,
Yeah.
I guess that really brings us to the issue of the grippers, or the question of the grippers.
Yeah, each position of the gripper is a certain diameter. You can find that information online at haascnc.com.
Yeah, we've got a bunch of layout drawings that show you, what pin position here or what finger position correlates with what size diameter. But in reality,
I didn't go online to look at it. I just eyeballed it basically.
You're gonna eyeball it.
It's that easy. So there's a lot of clearance on that. So
yeah, the jaws themselves have about a 1/2 inch stroke,
Yeah.
and so like 1/2 inch on each side of the diameter.
Yeah.
So you've got plenty of leeway for picking up your part.
yeah, if you can set your hard jaws to a position to load your chuck, to load your parts in your chuck, this is 10 times easier.
Oh,
So,
it is about the same thing. It's pretty easy. You can do it all just by eyeball, really.
Correct.
And if you need to, of course, this is what the machine comes with. But you can make your own custom pins. You can even make your own custom plates to mount on the jaws here. So there's a lot of different ways to pick your parts up.
Yeah, you got lots of options, not just the 3 templates. It also has 3 templates, small, medium, and large for the bars as well.
Right. You'll see. Yeah. When we get into the control here and look at programming it, you'll see that there's a selection for bar stock, and that's more like a couple of V blocks that the bar sits in.
That's it.
So we've looked at the templates and the grippers. Let's move over and take a look at how we program the machine.
Okay.
So Bob's going to take it out of APL mode now. So that's the automatic mode that it runs in when it's running in conjunction with the program in the machine. And so now we're moving into how you're going to program it. And it's really, go for it.
Yeah, there's 4 tabs to set up. There's a template tab, load tab, unload tab, and run job. And each tab has a series of questions that you just enter. Real simple, real easy.
And you've got those on-screen animations which really help you out. You've got a description line there of what you need to do in each case, but the animations really simplify understanding what you need to do on each part of the tab.
Exactly. I mean, we can go through the template right now and see.
Yeah, we'll start at the top and make our way through.
Yeah, the first thing it's asking is what kind of part is it? Is it a bar or a slug? And we've already got the slug in there. It's already set up. Number of rows, simply how many rows have you got? Number of columns, same question, real simple. Distance between the rows, now these these numbers are already in the control already.
Right, yeah. So we have these
Yeah.
3 templates that come with the machine. And for those templates, there are preloaded programs in the control which correspond to those templates and give you the preloaded dimensions between rows and columns.
Exactly.
But if
yeah.
you were to make your own, then you're going to
Yeah,
enter
then
your
you
own
can,
values.
you can work out your own. It's just as it shows there, from the center of one slug to the center of the next slug.
Right. You just have to remember, whatever custom template you make, the distances between each point on the row and each point in the column just have to be the same down, you know.
And you don't have to be too accurate. I mean, you can use a caliper, but a ruler's fine as well.
Yeah. Okay, so that kind of finishes, yeah, so that essentially in the template tab, you're just telling the machine where the parts are at and how many parts you have.
And then shall we?
Yeah, let's go through several steps on lining up
So
on the load tab.
Second tab is load. So we'll reset the machine again.
It's twice today.
So we'll get that going.
So we're taking the machine parts out of there. So this is if we're setting it up for the first time now.
And we'll go through the recovery.
So it looks like we have a lot of questions here, but it looks like Marcus from our products group is doing a good job of answering these. These go flying by so quickly I can't see many of them. But like I said, we'll answer some of these at the end as well if we don't get to them. If Marcus probably going to handle all of them before we even get to them. That's good. Okay, so let's...
Yep, we're on the load tab. First thing he's asking is what position the gripper's in. Is it ID chuck or OD chuck? You can see we're on the OD already set up. So first position
am I
is
plugged? Okay.
First position is initial pickup location. So the animation's showing you quite clearly what to do, and it's saying jog the APL to above the slug for the first pickup. Now we could do that from the position it's now, and it'll take a while to go across and come back down manually jogging, or with the jog handle, or there's a cool feature on here. Press insert, and the APL will wrap it there for you. It's a cool feature that this application
just gets you into position quickly. So even if you're over above the door, you press insert and it will move all the way over here.
Correct.
And now we get to show off the remote jog handle.
Yeah, so we've got the remote jog handle here. Graphics are showing. Jog this above the part and capture a location. Jog handle, because you can't do everything by the control when you're working over here. This is the newest jog handle we've got.
Yeah, so this is the touchscreen RJH, and it's I got to say it's significantly easier to use than the previous one. It's maybe hard to see here, but
maybe.
all the Bob has to do is just press the axis on screen that he wants to actuate, or any one of these other buttons, as it were, and it's all just done from the touchscreen.
Yeah, when you're setting the APL, you can pretty much do everything here. You can flip the APL grippers, you can clamp, unclamp, so there's a lot you can do with this. You don't need to keep walking back to the control. It's cool. Okay, so
get out of your way as you do this.
Yep. First position it's saying is, I'm just trying to get it above the part. I don't know if you can see that from there.
Yeah.
I'm gonna have to get in the way in a minute.
That's right. So all of this, you're pretty much just doing this by eyeball the whole entire time.
Yeah.
You're just moving these 3 axes. AW, of course, is up and down. AU is back and forth across the bridge. And AV is back and forth, forward and back on the table.
Yep.
And you're basically just lining that up until your jaws are centered about the diameter of the part, right?
That's exactly right. So, I'm going to check that position just to make sure I'm close. I'm happy with that. I'm just clamping and clamping with the remote jog handle.
Right, so you can clamp from the RGH right there, and then, like you're saying, as you're clamping it, you're noting whether or not the part is moving as the jaws grip it, and that's kind of an indication of whether or not you're on center. And
the cool thing about this is there's no calculations, there's no programming involved. It's just capturing positions. You let me say that quite a bit because it's just capturing that position.
Right, you don't have to somehow take these axis numbers and enter them into the controller. You just press record on the RJH.
Yep, I can press record here or go to the screen and press F2. If you look at the screen right now, I'm going to press record and those positions will change from AU, AV and AW to the new ones.
Unless you already did it.
Yep, no, just did it right now.
Okay, cool.
Okay, so we're just going to clear that. and we'll move on to the next.
Yeah.
Next line. The next line shows ready location. And if you look at the animation, it's telling you basically to take the part all the way up in W, go halfway across, flip to the load position, and then come all the way across in the U-axis. Now that's going to take me a long time.
What are you leading us up to, I wonder?
What's this leading up to? We've got the one button touch again that will do this for us. So if I press insert, it's going to wrap it up, flip to the load position.
Right, so that's getting the raw slug ready to go into the chuck.
Correct. And it's going to take me somewhere near where I need to be, above the machine.
Right, so the ready position is essentially the position where the arm is clearing the right side of the enclosure here and clearing the chuck on the way down on the left.
Yeah, so that insert feature got me to this position. It's not where I want to be. The ram will hit this sheet metal, so I'm just going to adjust this slightly. Okay. I like that position. And same thing again, to capture that position, it's just one button, press F2. Gripper swap location is in the ready location now.
Right.
So,
all right, so let's move on. So we set that.
Yeah, the next one is probably the most important. It's a safe axis location for load.
It's a long name.
It's a long name, just trying to get the turret away so there's a clear path for the APL to come down, load and unload safely.
Yeah, it's positioning the machine. It's the machine side of the positioning that allows this thing to have clearance. So we've just set where the arm's going to come in at. Now we have to make sure that that all of the axes are backed away and the turret is in the right is on the right tool for clearance.
Yeah, as you can see by the animation again, it's showing that there may be a hindrance. So index to a safe position.
All right, let's do it.
Yep. Just going to follow the graphics. I know, because we've done this earlier, tool number 7 will clear
We've
the
done
ram.
it a couple times.
Yes. And we are fully up in X and away in Z. We also need to be fully retracted in Y as well. Now, that is a safe location, I know already, but you can always come down and check and make sure you're not going to hit anything.
Right, when you're first setting up, you're certainly going to do that. Yeah, X and Z are backed up all the way, and probably maybe the most crucial thing really, they all have to be backed away, but Y-axis, particularly on a small lathe like this, is going to have to be backed all the way down away from it in order to clear.
Yeah, on the larger lathes, you might be able to get away with it with a longer Z travel and get away with a Z only. So,
right.
But the same thing again, Andrew, just one button. F2 captures those positions. You're ready to load and unload. Well, you're ready to load right now.
Right. All right, let's just keep going through. We're not going to show you line anything else up because it's all pretty much the same. When you get down here to the chuck load position, that's perhaps the one that you have to be the most careful with.
Yeah, because your jaws haven't got as much travel as your APL grippers.
Right.
So.
But this thing's right on center, so it's not a big deal.
Yeah.
Just careful eyeballs enough.
Yeah. Same thing. So after you've loaded the part, program the unload part, same series of questions, just simple. Hold on.
Yeah, let's go back to the top of the unload tab there, if we can. So once again here, it's going to ask you which way, how you want to grip the part. Right now we're gripping it on the OD, and you're gripping it on the OD when you're unloading as well. But you can, if you've got an ID feature that you'd rather grip on, maybe you have something else outside that you don't want to grab on, then you can do that.
Exactly. Gripper, rotate, delay, pick up location. So there's all the positions that we just did, it's just that in reverse. That's what it's going to be.
Right. So let's just, I think maybe one thing to mention is it's pretty much all the same. The point at which you flip the jaws to load the raw blank, that's kind of a crucial step. The only thing being that you can tell the machine either to do it down here on the work envelope as long as you have sufficient clearance.
If you don't, you can do it. There's 3 options: in the machine, above the machine, and above the APL table.
Right.
So,
right. You can kind of choose whatever you want. You know, if you've got really large live tooling in here or something, then you might choose to do the swap up here.
Yeah. You've got to be careful with the long shafts. If you do it here, you may collide over there.
Right.
Or with the bottom of the.
Right. So that's why you might even choose to do it over here.
Yeah.
All right. Well, let's move on to the run job tab.
Run job just tells you the current status of what's going on. So the current parts, how many is ran, what number is the next part on the table.
Right, we mentioned this maybe a little bit in the very beginning, but here we have this, we've got 24 parts on the table, but we could choose to run a smaller quantity than that if we wanted to, right?
If you've got 2 life issues and you only want to run half a table, you can set the run job template to run that many parts. And you can also start it from wherever you want as well.
Right, right. And then that page is also going to give you different status as to where, like if you walk up to the machine, this is the page that's going to give you the current status of how many parts you've run, what's left to run on the table, and the status of the APL overall.
Yep.
And then this is also where we turn the APL on to automatically work automatically.
It's just so right now it's not in APL mode, it's just in standalone mode, but one button press of insert will put this machine in APL mode,
Yep, and that's it. So basically you have your program loaded, you have the corresponding APL program loaded.
Yep.
Go in here, press insert, turn on APL mode on, press cycle start, and away you go.
Easy as that.
Easy as that. All right, I think that's about it on this machine. Marcus is doing a great job answering all these questions here, so I think I'm going to hold off until we get done looking at the mill APL to answer any remaining questions that he'll hand me, hopefully. So we're done here. Let's move over about 10 feet, and we're going to say hi to Milton here in a second as soon as we do a quick handoff of the receiver so we get audio. Once again, you guys, thanks so much for joining us. We're over 600 viewers right now. You guys are just endless comments here. It looks like we've got people from all over the world. So glad you guys could join us. All right, this is Milton Ramirez, another product specialist here at Haas, and we are of course standing in front of the brother of the lathe APL, I guess, automatic parts loader for VMCs.
Yes. There's a lot of similarities between this APL and the lathe APL. Obviously, it's a 3-axis automatic parts loader, and we want to show you how it works. So this is the best opportunity to do that.
Yeah, so we're going to just run right into a quick demo here.
Let me explain this part first, because I guess it's just to kind of get an idea of how beneficial an APL could be in a shop. This is a typical 2.5-minute part, and that includes an air blast cycle that we have to clear out chips and coolant from this part. So we have 10 rows of 6 parts each here on the table, so that's 60 parts. If you do the math here, 2.5 minutes per part times 60, that's 3 hours worth of machining time. So for those 60 parts, the APL will only add 30 minutes to that. So in 3.5 hours, you can do 60 parts. Those 3.5 hours, the person running this machine can just walk away, do something different, go run another machine, another APL, or anything else that comes up in every shop. So it's typically unattended, as we call it, lights out, whatever you want to call it, but it's automated machining. Okay.
Cool.
So I'm ready here to run this part, just so we can see what the motion's like. I'm going to switch to APL mode. Another good point is that a part program is independent from the APL program, right? So, but at any time, we can associate them. So we always recommend saving your part program with a similar number or comment as the APL program. You can save as many APL programs as you want inside of the controls memory. So, it's always good to associate them, have them ready, and always do a fast, quick setup, okay? So we're ready to go here. I'm going to press cycle start.
Cool.
So this load is pretty fast, as you can see. We have a pneumatic vise set up on the table. It's loading part number 1 right now. As soon as the APL gets out, the machine will start running. And just like the lathe APL, if the light curtain gets interrupted, we can stop it at any time. But the good thing is only the outer motion will stop, and the machine will keep running and making your part, right? Recovering from this is pretty simple. We just press cycle start again, and off it goes.
Right.
Okay. The machine's grabs the second part, obviously, and is ready to load. As soon as the part finishes, it will unload and reload the new part, right? So if your part's longer than, let's say, 40 seconds, 50 seconds, then the APL will never be waiting, or the machine will never be waiting on the APL. The APL will be faster than the machine or the cycle itself.
Right. So you have to have a really short cycle time part to beat the APL, basically.
Exactly, yeah.
And even so, even if you did, I mean, the APL is still doing all the work for you in terms of loading the machine. So even if you had to wait, you still don't have an operator who's sitting there doing that.
Exactly. So for demonstration purposes, I reduced the cycle time of this part to 58 seconds, I think it was, just so that we can show how fast the APL is. Right now we're air blasting the jaws so that they're clear of chips, so we're ready to load the next blank.
Right, that's the reason that the arm left the enclosure, closed the doors, so you can blow it clean.
So we can blow it clean, exactly. And, it's good to know that we do provide the air provisions on the table. The air provision is to blast the jaws and also to feed the pneumatic vise, right? You can use any readily available pneumatic vise out there, and as long as the what do you call it, the size of the jaws and the speed of the vise are fast enough, it won't slow you down. So
right. So let's I guess we got 30 seconds left on that thing.
Yeah, we'll stop it.
Maybe let's talk about templates on this machine for a
Okay.
minute. So the templates on the mill APL are a little bit different than on the lathe. We don't, at this point, we aren't providing templates just because the potential for variation in part size is so great with a mill that.
Yeah, exactly. On a lathe, pretty much they're always going to be round. So,
right.
So no, that's why we provide 3 templates for all different sizes of round parts. But when it comes to a mill, I mean, we could start with. Sorry about that. Just don't want to get in the way of the robot.
Yeah, there's a lot of different ways you can make templates, of course. Here comes some questions.
So just wanted to show you this blank. So most of the time on a mill, it's going to be square, but it could also be a different, an odd shape.
Yeah, rectangular,
right?
or
what you really want to achieve when you're putting your parts on the table here is just an actual stop in X and Y direction, if you will, right? So it doesn't need to be captured. It doesn't need to be held in a certain position. Just stopped in a repeatable
so
position.
you could even maybe use a pegboard style
pegboard,
thing.
yeah.
You could cut something out of a thin piece of flat plywood, and there's a lot of different ways. It doesn't really see any wear.
Yeah. Another important piece of information is that we have dowel pins on this aluminum table, which allow you to locate any custom-made template on there. So when you're done with the job and that template's not going to work for your next job, you can just remove it and put your next template on really quick.
Right.
So
and when you return that template, your position is going to be still going to be maintained.
Exactly.
Yeah.
Exactly.
Same thing on the lathe, of course. Yeah.
So as long as you associate the template with your APL program and your part program, you pretty much have a kit to run another batch of parts again really quick.
Cool. Yeah, and then the grippers are kind of similar. In fact, quite similar. You've got the same kinds of pins, or fingers as you might call them, and then the mounting plates for those fingers.
Exactly. On the website, we have ready available the operator's manual. We have the machine layout drawings for the footprint of the APLs, both of them. And that also includes a drawing of the grippers, right? And it also includes a chart that tells you what holes to put the grippers in to pick up certain sizes of parts, so you don't have to guess, right? It'll
or
show
you can just guess, like I would probably do it and eyeball it and get it wrong a couple times, but it's pretty easy to figure out. Certainly not rocket science.
Exactly. So for the custom grippers, all you have to do is go check out those drawings and look at the mounting bolt pattern and then make your own shape. You can make them out of Teflon, out of aluminum, out of any soft material you want, so that you don't mar your parts if they're delicate. Right.
So do we want to move on to take a look at the screen and how we program this?
Yes.
Luckily, I mean, the APL and the mill APL and the lathe APL are very similar. So if you're fortunate enough to already have a lathe APL in your shop, this is just going to be super easy. I mean, it's really just a matter of some of the differences of how we clamp the part, how the arm moves back and forth.
Exactly.
But overall, it's very similar.
Let's go to the control then. Okay, I'm still in APL mode right now, so I'm going to get out of that mode just by pressing the insert button. So now, even if I ran my part program, the APL is not going to move.
Yeah, and that's, you had kind of alluded to that earlier. One of the beauties of this is that you can switch in and out of APL mode, you know, at your whim, and the machine operates just like your regular VMC, the regular VF2, at the times when you're not using it with the APL.
Yeah, basically a standalone mill. And also the good thing is, let's say you stopped the mill from running automatically on part 5, but then you do something, you change a tool or whatever, but then when you go back and you want to continue running the APL, it knows it was at part 5 and it'll continue from there. So you don't have to start over. So that's really good as well. Okay, so now the control. So it's pretty much the same as the lathe APL, which it consists of 4 templates or 4 tabs. The first one is where you define the template, okay, and you define the gripping style, if you're going to hold it from the outside, if you're going to hold your part from the inside. So you're basically just answering the question like you would on a form. Okay, so the next one would be the rows. And what I really like on the control is, okay, so what is a row? Is it from left to right? Is it from front to back? The control will actually tell you with an animated GIF file here. So it's telling me that the number of rows is from front to back on the table, and the number of columns is whatever I have from left to right on the table as well. So this is going to vary depending on how many parts you want to fit on that table. You can enter 15 here. You can enter, 10 if your parts are really small, and not a problem. And then what really is important here, the distance between the rows always has to be the same. It could be anything, but it always has to be the same. It has to be consistent. The distance between the columns, they can be different from the distance of the rows, but they also have to be consistent between them.
Space to space has to be even in each case, going up and going across.
So all columns have to be the same distance, all rows have to be the same distance, but rows and columns can be different.
Right.
Okay, so those are pretty much it, the questions for the template.
Yeah, you're setting up what's happening on the table, basically.
Exactly. So then we go next to the load part area. And these are interesting because these are some delays that are between the time you drop your part in your vise and the time the gripper is going to release it, and then it starts moving away from it, right? You can. Those are changeable, but it defaults to 2 seconds.
Yeah,
right?
we have delays here at this part of the program, and then we also kind of have a global delay at the very end of it, which can allow you to slow the entire thing down when you're kind of first setting up the job and you want to make sure that everything's set correctly. But this is kind of this is the one that's going to persist even after you're kind of in production, as it were.
Exactly. This is the initial pickup location is the next row that we do on this tab, and that is the location of the pickup on the table, right? It's always going to be the same part or the same location. When you have a full table, you're going to program it from the top left. So that's your pickup location. Your drop-off location on the next tab will be the exact same position as well. Okay, so
yeah, in fact, on both the mill and the lathe, really you're only programming the first position on the template in either case. That's where you pick up from and where you return the part to. Then of course, the control calculates all the rest of the positions on its own.
That is correct, yes. So this is the only major difference between the lathe and the mill. It's just the internal access location for load, right? That one is because the table actually has to move inside of the machine to position itself to make the vise available to the APL. So when you actually move your X and Y table locations inside of the machine, you're also going to move your A and AU axis on the APL. Once those match and you jogged it and you can pick up or drop off your part to that vise, then you simply press F2, right? As Bob was demonstrating over there, you don't really have to enter any numbers. You don't have to do any math. You just simply position yourself where you're comfortable dropping off that part. For your drop-off position, you press F2, and that'll populate, a couple of rows here automatically.
And just like Bob was showing, typically you're going to be using the remote jog handle to do that program because you're going to be over here, lining up the jaws with the part. And this one has the same touchscreen remote jog handle as the lathe did.
Pretty much the same touchscreen. You can navigate just by touching the axis you want to enable, right? Use the dial to move around.
You can clamp and unclamp the parts there. You can do the quick auto moves.
Exactly. Last time I dropped the part here, and
yeah, at least you're ready for it now.
This time I caught it. So yeah, you can open and close your grippers from here. You can do the same over here. Oops, I still dropped it.
There you go. You got it in.
So yeah, so you can also you jog the axis, obviously. You can set work offsets. You can, when you're running your part, you can do single block mode. You can do, cycle start. You can do, stop.
Right, all the typical RJH
stuff from the remote jog
functionality.
handle as well. So very useful piece of equipment here that comes with the APL. All right. So
Cool. So that's pretty much the load tab.
the load tab, yes. The unload tab is pretty much the same location, except the only difference is that now you're going to go from gripper number 1 to picking up from the vise with gripper number 2. But you're going to do exactly the same thing. You're going to position yourself to where you're comfortable opening and closing the grippers and over the part. And once you're there, you just press F2, and again, that records the positions as well. So this might seem like we're going a little slow, but when you're familiar with the APL and you know what positions the APL needs to know before it can run, you can do this in 15 minutes with a new part, and it shouldn't be a problem to do it that fast.
Yeah, and the beauty of it is that, this is what I've found, is that once you've programmed a couple of parts, if you have a part with similar geometry, programming that next part is going to be quite a bit easier because many of the positions are going to be the same or super similar.
Exactly.
So actually your first program or first programs is almost kind of a roadmap to those that come after it.
Yeah, you can actually use, if you're going to do an APO program that's similar to the previous one you did, but for some reason you have to make a new one, then you can load that one as a template and just do modifications and then save it with a different number, and that'll work as well. It speeds up the process. Right. So again, you can save a lot of multiple different APO programs. You won't have to do this programming thing all the time. You only have to do it once for your part, once for your particular template, and that's it. You can run batches and batches and batches of part, but you don't have to program it again.
Right. And as you were saying, your typical procedure is to name the APL program similar to your part program of course, just so you don't get confused. And,
exactly. Or at the very least, add it in the comments, right? This APL program goes with this part and this template, and you're good.
Right.
So do we have any questions that we want to do?
Yeah, let's do some questions. I mean, that's pretty much it. I mean, the run job tab is the last one.
That was the last
similar
one.
to over here on the lathe.
Exactly. The first 3 rows are counters, basically, to keep count of where you're at on the table. And when you're ready to start over, you can just reset them by pressing origin or just entering 0, right? And
as we did over here, if you want to run less than a full table, or you want to start in a different position on the table, you can do that from here as well.
Yeah, that's pretty interesting, because if you have 60 parts on the table, but you just want to run 10, you can actually tell the APL to just do 10, and it'll stop when it's done. Or if you have 60 pieces per table, but you want to do 120 and keep count on the machine, you can do that as well. And the APL will prompt you to reload the table and then continue without a hitch.
So we talked about this a little bit earlier, but we did get a question here. Can you slow the APL down? And the answer is yes.
That's a perfect timing. Because we're right here on the Run Job tab, okay? And this has a global override for the whole APL. So if I set this row right here at 50%, all the APL motion will be at 50%. We don't necessarily recommend that unless you're just setting it up and you're not very comfortable yet with the APL. But we do recommend that once you're running and your setup is good, run at 100%. You'll never have a problem. Okay, but that's just a global rapid override. Now, if we go a little bit lower, there's a slow rapid distance. And that applies to, how soon do I want to start slowing down before my grippers come into contact with the part, right? So typically I'll say about 4 inches, 100 millimeters above the part, I'll slow it down to 10% rapids, and it slowly approaches the part, and then it grips it.
But then you're also probably going to tune those. You're probably going to speed those up as you become comfortable with the fact that everything is correct in terms of alignment and everything else and timing.
Exactly. If you're comfortable, if you have enough room on your jaws and your grippers and your part, then you can actually do that at 100% rapids. It's not a problem.
Cool. All right. So we have Jeremy Tomes asked, can this be added to an older machine, or does it have to have a new machine and controller software?
Oh, that's a good question. Since we've added so many new features to the APL functionality, it really has to be, at the very minimum, it has to be an NGC machine.
For sure has to be an NGC machine.
Yeah, new generation control at the minimum.
Here's another question. Do we have other gripper options, including vacuum perhaps?
Yes, you could put vacuum here, but it would be a custom job. It's not something that Haas offers from the factory, but I know of customers that have done that before. They can add vacuum here. It's just basically, you know, a simple setup.
Yeah, and one of the questions that we had come in earlier before we started the stream was, can we adjust the pressure of the grippers for very thin wall parts? And once again, the answer is we don't provide that out of the gate, but
that is correct. Not from the factory. We don't have any adjustments or anything, but also customers have done that because they do have thin-walled parts or parts that are sensitive on the surface and they don't want to mar them, so they do reduce the gripper force. Right now we have it at 100 PSI, 110, whatever's coming into the machine, but you can regulate that down. Yeah, minimize it and control it with...
I think you'd have to have a pretty thin-wall part before you'd run into any issues.
Exactly.
Right now, as it stands now, this thing can pick up a 10-pound part, right?
Correct. That's right.
So
that's
pretty decent weight there.
Yeah. The table can hold 1,000 pounds, but you're probably never going to get there. But 10 pounds per gripper, that is correct.
Okay. Let's see. How difficult is it to integrate the APL with the machine?
It's not difficult at all. Obviously, we designed it that way, right? So it's something that could be done within a few hours in the field. Leveling it, that's another story. Aligning it maybe takes longer than the actual connection and making it work, or handshake, right? The handshaking is really simple.
Right, yeah.
So plug and play, basically.
All right. Whoa.
And really important too is that all the programming and the interface is on the Haas control, so you don't need any third-party controls or any pendants or anything else.
Right. Everything you need to run the APL is all here in front of you right here.
control.
The machine and the RJH, and you're ready to go.
Exactly right.
In terms of the pneumatic vise there, this is now this is an off-the-shelf one that we have adapted here.
Yes.
And there may be vices coming down the line offered by Haas. We're not really talking about those right now because they're still in the early development stage. But
they did see that it says HaasTooling.com.
Yeah, look at that. So. It does say HaasTooling.com on our shirts, right?
Yeah.
So you'd probably be buying it there when it becomes available.
Exactly.
But there's controls in the machine for controlling an e-vise or a pneumatic vise, that sort of thing. So there are provisions to control it from within the APL software, but then there are also on our mechanisms page. You can control a vise there as well.
For example, if I have a custom vise, which is what we're calling this one because it's not made by Haas or sold by Haas, you can just go to the custom vise tab over here and just by pressing F2, open, close, open, close. And the same when you have an air blast, you can do that as well by pressing F2. That's blasting my jaws right now. And any other attachment or accessory that you have on this machine, you can control from this one tab called the device tab.
We have another question here. Idris Ishak, it looks like. Does the APL need to be aligned with the machine itself? And for sure it does. And that's something that your HFO tech is going to do for you.
Yes, the installation instructions clearly say what alignments are most important on this. But definitely level and align to the machine is required.
Right, for sure. Same with the lathe APL. Well, I think that's about it for us. Thank you very much, Milton. I'd like to thank Bob also. Great information. And I think we're going to send it back over to Brian and Corey, who are standing in front of the Haas robot.
All right. Thanks, Andrew. Appreciate it. Andrew's just about 30 feet that way, even if it seems like we're in a totally different location. A couple quick things. We had a couple of comments. One was vote for Mark Terryberry in 2020. And we want to say he's got our full support, and he will be announcing his candidacy on a live tip of the day here upcoming. Also, apparently I said something to the effect of I'm the only one at Haas that doesn't have to wear a mask. Obviously that's not the case, but thanks for pointing that out. All right, I'm here with Corey Sullivan, product specialist. We're going to talk about the new Haas robot package. Now, Corey, a couple of things. When somebody hears robot, they think two things. They think price and they think programming/integration. We've addressed both of those. The Haas robot package is under $50,000. It's $49,995, and the integration could not be simpler. So let's talk about a little bit about how you connect the robot and how we integrate it and teach it how to move.
Yeah, so the integration's really simple. Obviously they're both plugged in, powered up. And this is just an Ethernet cable that goes from the robot into the machine, and that's it really. So from there you'd come over onto your robot interface section. So this tab over here, and you see there's a button that says F1, and that has for setup options and connect.
We're good.
So that's it. Once you do that, you're connected.
So Ethernet cable connection, I think we might have had a problem with my audio, which is probably my fault. Connect the Ethernet cable, go in there, literally hit connect, and you're done.
Yeah.
Okay, that couldn't be easier.
Yeah. There's
Okay, go ahead.
Once you're connected, you could just start controlling it with the remote jog handle while you're on this tab. You have to be in handle mode.
Okay.
So we have 2 different methods of jogging it. We have what we call linear mode and what we call joint mode. Linear mode controls it similar to any 3-axis mill you're used to. So you have your X, your Y, which goes forward and back, and your Z, which goes straight up and down.
So you're, just to be clear, you're where you would normally do it on the control pendant, you're changing axes on the remote jog handle with the touch screen, and XYZ, just like you said, like a mill table.
Exactly.
Okay.
I should have clarified also that the default is the base of the robot. So we have a method in here to set up your own, what we call a user frame, and that basically will set your X, Y, and Z planes and axes.
So the robot is mounted at a 30-degree angle.
Yes.
Now we have to teach the robot that the parts are flat, in this case, 30 degrees off from the base of the robot.
Yeah, and we have a couple of methods of doing that too. If you know exactly what you want, there's a direct entry and you can just punch in the numbers. Or what most people will probably use is the 3-point method, and that you will come down, touch the table, just like you're setting any other tool that you're used to in a mill. You know, you can set it with a piece of paper or whatever. Record that position. Just come up a little bit so you're not dragging across the table. Go back down to that same exact Z and X.
Okay.
And it'll touch there, since your X is exactly the same.
So you're moving in one axis and you're touching twice.
Yes.
Okay.
From there, the Y will actually go up and away at that 30-degree angle you can see it's mounted at. So it'll go up, and then you come back down, and Z which will go down and away because it's perpendicular to the plane of the base of the robot. Then you'd touch off that same piece of paper like setting a tool.
Okay.
Record that position. Since your first one was from here to here, that sets your X. Second one from here to here, that sets your Y, and it knows your Z is perpendicular to that.
Okay, so 1 point, 2 points, 3 points, and now you've taught the robot that your parts are sitting on a flat plane.
Yeah.
Okay, easy.
Easy. And then, yeah, it's just straight up and down from there. So you can, so that's X, Y, Z, like I explained a little bit ago. And then there's 3 more in linear mode for the robot, which is W, P, and R. And that is essentially the rotational axes around the other ones. So the easy way for me to remember is WPR is the same as X, Y, Z. W rotates around
X. Okay.
P rotates around Y, and then R will rotate around Z. And just to show it real quick, that's W going around that X axis. P going around, rotating around that Y axis, and then Z, or R, sorry, rotating around the Z axis.
Around the Z axis. Okay.
So yeah, the second mode is joint mode, which is you control each individual robot joint separately. So this robot has 6 joints. Basically just counts from the base of the robot up. Joint 1, 2, 3, 4 is this rotational one. And then 5 is at the bottom there, basically what I call the wrist. And then the 6 is rotating around the end of that.
Grippers. Okay.
So just to show that off real quick. So joint, so it's very different from your X, Y, Z.
Okay. It's pretty simple though.
Yeah.
And again, you step through all those axes on the remote jog handle.
On the remote jog handle, yeah.
Okay.
So joint 2, just to show a little bit different motion there. Okay.
Okay, that's pretty simple.
Yeah, that pretty much explains how you jog it. It's pretty easy to use. So I'm going to just return it to the position I left it at before, which I'll show you how we set that point, that returning sort of home position.
That's what we call a safe position.
Yeah.
Okay.
So that's over here. So the first thing you're going to do on the robot is very similar to the other APLs that we just explained. It's, you set your part type, slug or puck, number of stacked parts, number of rows, columns.
It's the same templates that they were showing us on the APLs.
Exactly, same template. The new parts are here towards the end of this tab, and that's part flip, which is one of the things the robot can do that the APLs cannot, and that will enable a few extra fields for you to fill out in your unload part tab and the run job tab. Basically where you would set up, you can have it set the part down, pick it up from the other side, and load it back into the machine.
So if you have a 2-op part, you machine op 1, the robot sets it on a stand of some kind and comes in and picks it up from the other side.
Exactly.
Okay.
And and then on the run job, you'll have two different options there too, which is program 1 and program 2, where obviously you're not going to run the same program for both sides of the part usually.
Right.
So it will know when to switch between programs too. After it's done the part flip, it'll automatically run your program too.
Got it. Okay.
There's a couple new fields here in the template tab also, which are the gripper net mass, raw stock mass, finished part mass.
And so what we're doing here is we're telling the robot to account for the weight of the parts, and that affects the movement of the robot. It needs to know roughly how heavy the parts are, the raw stock, the weight of the grippers themselves, and then the finished part.
Exactly, just so it doesn't overload any joints or damage itself in any way.
Simple enough.
So that's pretty much it for...
So again, like the APL, when we're programming this, it's just like the APL templates. We're just stepping through a series of questions, basically, on the VPS templates, answering questions. Answering questions, and there's some GIFs to help you, too, that explain what exactly we're asking for with those questions. The first couple on the load part are same as the other APLs, too, where you have your clamp delays. And then here's the speed. This speed on this part will only show, or only be used for when it's placing parts around the table, because since we're doing it number of rows, number of columns, number of parts, you don't have to make all those motions custom yourself. So that's the speed it will use for those motions. So it already knows, you've already set up the distance between parts and columns and rows, and now you're just one setting tells it how fast to go between parts?
Yeah.
Okay.
Exactly.
Okay, that's easy enough.
And then here's the first part or position that you're going to set, and that is the initial pickup location. You basically just jog it down, clamp the grippers, and press F3 to close the grippers, and then F2 will record the position. Just like the APLs, exactly the same.
Now, again, just to reiterate, since the control already knows the distance between parts and how many parts are on there, we're only setting the initial pickup point, correct?
Yes. Yeah.
Okay.
So based on the distance between rows and columns that you inputted on the template tab, and the number of parts that are there, it'll do all of that for you.
So we're teaching at one location.
One location.
Okay. So we're using the jog features, and again, just like the APL jog features to get it over part number 1. We clamp the grippers, hit F3. F3 or F2?
Yeah, F3 to clamp the grippers, and F2 will record the position.
F2 records the part, okay.
You just want to clamp the grippers, and I like to clamp the grippers and then move the part into the exact location I want it, so it makes it a little more exact, because if it's a little off, you can clamp the grippers and it'll move the part a little bit.
Got it.
So I usually clamp it, move it into the exact spot I want it, then record the position.
Okay, so now we've taught the machine how many parts, where that first location is. What do we do next to start teaching it motion?
We got one more spot before we'll go to motion, and that is the move to above tail position, and that is that safe position that I described earlier. You just pick that part straight up in Z, and it would probably be around that spot. That's actually the spot that I had said earlier. So it's above the table enough that when it picks up the last part, it won't come out and take out the rest of your parts on the table.
So you just want it higher so it doesn't, high enough so
Yeah.
it doesn't hit something.
And it's a good starting reference point to return to a lot of times when, you know, before you start doing anything. I like to put it in that spot. So it's kind of like your home position. You want to start from there. So now you can see on the interface here that this is asking for something different.
Yeah, that's not a position. That's a
Yes.
that's a file of some kind.
Yes, it's a file extension, and it's very simple to do. You will record this by you just go over to the robot tab here and the recorder tab, and from here you'll create a file and then you load it into that spot. That file is just a series of points, basically. So you
So
need
it's
to have
connect
more
the
than
dots?
one point. Yeah, it's connect the dots. More than one point along the path to get here, because if you just recorded this point, the robot can't come through itself to get there.
Got it.
So you need to do, you know, a point here and a point here at the
So we're going however many points, A, B, C, D, E, from safe position all the way to loading it into the machine, and you save that, and that's one file that is that series of points.
Yeah.
Okay.
So I'll show you one real quick just to show how simple it really is.
Yeah, let's do one.
So the first thing you do is you'll set, it says enter value. You have 4 options here, which are record position, set speed, APL gripper, which will actuate the grippers, or work holding, which will actually clamp and unclamp your work holding. APL gripper and work holding right now are controlled automatically in the APL sequence, just like the other ones right now. So the only time you'd really want to use these right now is if you're doing a part flip, because that includes grabbing the part, unloading the chuck, opening the chuck, unclamping the grippers, coming over to the side. So we don't need to do that.
You don't need this for this demonstration?
No.
Okay.
So the first thing is you'll set the speed, and this is set in millimeters a second. So I'll set 100 millimeters a second for.
What's the range there?
I believe we have it capped at 500.
Okay.
I think the robot can move faster than that even, but yeah, right now 500 is plenty fast for what we need. You're going to be waiting on your part machining more than you will the robot.
Got it. Okay. And we want to. You can always bump that up later after your program's proofed out.
Yes.
Right? Okay.
Yeah, you start it slow and then go a little faster.
It's like starting at a 25% rapid or something.
Yeah.
Right.
And the rapid overrides actually will change the speed of the robot as well. So if you're
They do. Okay.
when you're watching it for the first time and you don't want to crash, you can run that on 5% or 25%.
Okay.
So
you're going to teach it a series of points right now?
yes. So I'll just record this first value that we're already at to get it back there when we're done.
And all you do is record position and press 1?
Yeah. So I'll put it in joint mode here so that it's a little easier to understand for everyone, which is setup, set to linear, and then I'll set to absolute. And, it's changed over here, sorry. So over here on the jogging tab, you can actually change it between joint mode and Cartesian mode, depending on what you want it to be displayed as. I like XYZ because it's simple and
It's
easy
simple.
to use.
Yeah, you're used to it.
So you can see now it's XYZ on the interface frame.
Okay.
So here, I'll record that first point again. And I'll just jog the robot away. I'll make it a pretty big motion so that you can see it on the camera.
You see that, Tyler? I'll get out of the way.
And one thing you can do also is you can move it in joint and linear mode in the same motion. So say I did that, and then I'll do joint 4, so you can see that's a joint movement. And I'll go out farther in X, so it makes it a little easier to see here. I'll record this as point 2. Okay, I'll make a second point. Let's go.
So you're jogging now in the linear y-axis.
Yes,
in this
linear
case.
Y. So just come basically all the way out here towards the light curtain so you can see it. 1, 2, 3. How easy it really is. And I'll go up in Z even, show that. And then maybe I'll rotate joint 6 again. So I'll record this position. Now to run it, F2 is run options on this interface here. So we have run selected, run all, and run in reverse. Run selected will run to that selected point. Run all in reverse will run all of your points in reverse. And run selected will run yours in forward from beginning to end.
Okay.
We'll do it in reverse since we're at the end already.
Okay.
And here I'll slow it down to show that rapid slow in it too. And we'll run in reverse. You can see 5% is way too slow
It's
though.
crawling, yeah.
So we'll go up to 100 here.
So it's just retracing your steps, those 3 points that you programmed.
Yeah. So here we can watch it forward, just so you can see it just follows exactly the 3 points I recorded, which that was point 1, there's point 2, and that's point 3, and it just connects the dots.
Simple as that. So that's how you program your motion from picking the part up from the table and, in this case, putting it in the chuck.
So I'll put it back here to the start. So those are basically the only two. Oh, you'd hit File, Save here. So F3 File Options, save that file.
Okay.
And then you would select it right here in the ready location, or whichever one you're setting at the time.
Okay. So you're going to, obviously, if you're loading different parts, multiple parts, you're going to have different programs.
Yes.
And you go and select the program for the part you're running.
Yeah.
Okay.
So yeah, there's a couple different programs. I think for this there's like 5. We got ready, chuck load, and then the other ones are just coordinate positions, just like we showed earlier. Another cool thing about the robot here is you can see that you can load it. You can select your work holding. So raw work holding on here is the main spindle chuck. The robot can load into a sub spindle.
I was going to ask that.
A mill vise.
Okay.
Etc. So you can load it basically however you want. So let's go over to unload part. This is set in mostly the same ways as what we just showed. We got a couple files here, you can see.
So you've got a chuck pickup location. So
Yeah, so we got a chuck pickup location, which after it's done machining, you'll go and grab it, the part,
Okay.
out of the chuck. And then a gripper swap location. Since we have the dual gripper on ours, it'll come out inside the machine, rotate the grippers,
got it.
and put it back in.
Okay. So your part pickup, it'll move back. That's how it'll rotate.
Yeah.
You're picking up a finished part and you're swapping with the dual grippers and putting in another piece of raw material.
Yep.
Okay.
So then the load after swap, so you don't have to edit it twice. You can load. That's after you pulled it out and rotated the grippers. It'll placing the next part in. So
Okay.
and then the unload part, grabbing it,
Just
pulling
does
it out.
everything in reverse.
Yeah.
Okay.
We have another new thing to the robot here is the part drop-off method. And we have a few different methods right now. We have single table, which is what you're used to on the APLs, what we just showed. It'll pick up the part in one spot on this table, and it'll place the finished part back in that same spot.
Okay.
Symmetric dual table, so you would have a second table set up, and it would come and place the finished part on a second finished part table.
Got it.
Single point would be similar if you had a conveyor feed.
Okay.
You'd pick up from one location only, drop off
And
in
you'd
one
always
location
drop off
only.
on the conveyor. Okay.
Exactly.
That's pretty cool.
So I'll change that back here. Or I'll just load it actually at the end here. So you have an air dwell, rotation speed of the chuck for the air dwell to blow chips off or
Okay.
what have you. And the chuck delay time. This one's set, that one's just display only. It's just like, it's just how you set it in your settings normally in the Haas settings.
In that, okay.
Yeah. So then we have the Run Job tab, and this is the same tab as the APL.
Okay.
So I'll load my file since I just changed a couple options, and then we can. So that's demo day is live.
So same as the APL, you're loading your
Just double check.
demo program.
Yeah. So this is just to show how it's going to run from start to finish. And it's just like, oh, that's just, it timed out. The robot alarms appear on the Haas control as well, and you can clear it with the Haas control because you don't need a third-party, what are they called, the integrators or the Fnac pendant. So everything you can do straight on the Haas control. So you'll come back over. And
Go to Run Job.
11. And you can see right now we have it's a stock program. It just loads a part in, pushes it in with the spring pusher, and sits and waits for the robot to come around.
Okay, you're not actually doing any
We're
cutting.
not actually machining.
Got it.
So the robot is just like the APLs in that you can turn on APL mode now. And that means you can run your part program without the robot at all, or you can run it with the robot in APL mode.
Okay, so if you turn APL mode off, you're just running parts in the lathe.
Exactly, it'd run it just like normal without
Okay.
the robot. So you don't need to actually input any code into your part program to control the robot.
Got it.
APL mode handles all of that, which is very cool. So
Okay, so if we're gonna run,
we'll just show it.
make sure you can get in there, Tyler.
So that's that initial pickup location.
Now it's gonna come up to safe location.
Exactly. And now it's running that ready motion file where it's just connecting the dots. So this would be the chuck load location file where you just go in and it loads the part into the chuck.
Now if I were to trip the light curtain here,
Yeah, you can trigger the light curtain and
Okay.
the robot will stop.
so we don't alarm out.
We don't alarm out. I can just hit cycle start actually and it will return.
So it's like pressing feed hold.
Exactly. If it was to hit outside of here, when the part is actually machining, the machine will keep machining also. It's not going to stop the machine.
So
with
light
the
curtain is just for the robot.
Yeah.
And I should have mentioned at the outset that the light curtain and the safety cage, along with the robot, is all included in the package.
Yeah.
Pretty simple.
Yeah. And so my favorite motion is actually coming up right here, which is that gripper swap we
Oh yeah,
talked
Tyler,
about.
are you able to see the
Yeah, it's
gripper as it swaps? It's tough to see.
Comes in, it'll grab the finished part with the grippers number 2, come out, flip around to the raw stock gripper 1 again, and load that back into the chuck.
That's the dwell time you set.
Yeah.
Now it's going to come out to the retract position and then trace its way back. And now it's going to drop off the finished part wherever you programmed it to.
Yes. You can see there too when it's loading in, it's going much slower than here, and that's how you set the speeds.
So you set the speed in the machine much slower than once you're out. Once you're out, it's
Yeah.
basically 100% rapid, go back, get the next part.
Yeah, so if I was to hit 25%, you see it'll slow the robot down.
Got it. Pretty cool.
Yeah.
Do we have any questions on the chat? I think Marcus is hitting them all
Probably got them all.
pretty well. Yeah.
All right.
All right. Well, thanks everybody.
Other grippers?
Say again?
Other grippers available for it?
Oh yeah.
Other grippers available?
Other gripper options.
Yeah, there are. We have support for single grippers as well. I'm not sure if we have anything other than that.
Okay. It'll be coming.
Yeah, and it's one of the things where that's controlled mostly by the robot, so you should be able to add, I should verify that later, but Should be able to add your own custom grippers too.
Okay, for now, it comes standard with a single gripper. This
Yes.
double gripper option that you see here is optional. Okay, I think we're going to wrap it up. Want to thank everybody for joining us. I know it went a little longer than we expected. Real quick before we wrap up, I want to thank everybody who was involved, including the behind the scenes people. Hey, Marcus. So Marcus, with the blue mask there, was on the chat. Frank Zaragoza in the flannel there was command center, making sure that everything flowed smoothly. Orville Collins, if you watch our videos, you know who Orville is. He was monitoring and making sure nobody bothered Frank. Andrew, Bob, Sal, that's one of our cameramen. You guys know Milton and John, and Tyler, get yourself in front of the camera. And that's Tyler. Thanks, everybody. Really appreciate you joining us. We'll do it again next month. We're scheduled for Wednesday, July 1st, but of course, we'll send some notifications. Thanks for watching.